Hi engineering Janta, I am Vaibhav Shukla and today we'll be understanding the basics of circular queue. Primarily I'll be introducing circular queue to you. To all those who haven't studied the limitations of the linear queue or the normal queue, for them you must go and study that limitation, because here it will automatically help you understand better that why circular queues can be used or what purpose exactly do they solve. Fine. So without wasting any time, I'll go ahead and dive in deep into circular queues. So this is basically a circular queue. Fine. People are sitting on a round table and from here to here a complete circle of people is available, and this is basically a queue only. Fine. Because if I define that this is CEO, this is CBO, this is CXO level, all people sitting, then one by one they're sitting in a chronological order only, no? So this is circular queue. Fine. Now, the interesting portion about circular queue is we often don't understand that when we implement in data structures, how they work, how they get visualized. So for that, I'll draw a circular queue here with pen, and using that, you can just visualize how things can be added, how enqueuing and dequeuing happens into it. Fine. So for all those who don't know what enqueuing, what dequeuing means, these are operations. Fine. ये वो operations हैं जो queue में इस्तेमाल होते हैं और मैंने इनका प्रयोग पहले दिखाया है. I have shown how they are used. So you can go ahead, check the previous videos of queue. Fine. So let's try making a queue. Fine. So consider that this is a circular queue. Okay. And in this circular queue, I'll draw some memory partitions. So for that, I draw it like this. Okay. So these are the memory partitions. Masala box देखा है घर में? Consider it just like that. Fine. So in the similar fashion, ये बीच में there is no space to store anything. Okay. There is no space to store anything here. The only spaces to store are here only. Fine. Now, either you keep some spice, I'll keep some numbers here. Fine. So I put 15 here, or first of all, let's imagine this is absolutely empty. Fine. In that case, you know we had two pointers, front and rear. So in this case, front is equal to -1, rear is equal to -1. We often set it as 0, the initial values as 0 when we implement using array. The implementation of linear queue, when it was done in array, I deliberately set the values of front and rear as 0 to reset the complete queue. Fine. So for those who are watching the videos constantly, they know that how that functions. Fine. So apart from that, front is -1, rear is -1 here. Fine. In this case, when I add something to this queue, I'll not just stick to this queue, I'll keep drawing the stages of this queue so that you understand what's happening here. Okay. So now I add an element to this queue. Okay. And how many, what's the capacity? 5 is the capacity to it. Fine. So I guess it's 5. Yes, it's 5. So in this case, I add 15 into this queue. So rear is pointing here. Fine. Because whenever you enter anything, you enter it from rear in the queue. So rear now starts pointing it here. And if I further add something, I further add one more element. Fine. So I draw this queue again and I put a few particular disks here in this manner. And now I have 15 and I have 16. So the front would point here only, isn't it? And the rear would come here, because rear is basically being incremented every time a new thing is added. Rear points at the entry of the queue. I told you everything that enters the queue enters from the rear end only, and everything that is dequeued from the front end only. Fine. So the front pointer points at 15, rear points here, and then I go on further. And just imagine that I have added 2 more elements. So I'm basically skipping a portion of queue, and I'm telling you that in this queue, 1, 2, 3, 4 and 5. I guess now it's perfect. Yes. So 15, 16, 17, 18 and this is front and now this is rear. Fine. At this point of time, what I do is I perform Dequeue operations. So in that case, I Dequeue this, fine, and the front starts pointing out at another location. So now front is incremented, front is here, fine, front is here. Oh my god. It's not agreeing to be written, so let's try again and write it somewhere here. So front, I get this works. So front is pointing at 16, fine. In this case, this block is right now empty. Had it been a linear queue, there would have been a problem. Just imagine the same Dequeue operation that we were doing there, right? So whenever we did Dequeue, we added -1 value here, right? I am putting it in quotes so that you do not consider it another value like these, fine. So this is basically the empty space only, the space where nothing can be added. Now, right now, why nothing can be added? Imagine it in the form of linear queue. Until unless complete queue was empty, then only you had to reset. Otherwise, even if you have a single element left, you cannot add anything in the previous spaces, because that was the limitation of queue, if you correctly remember. Now, I push another element 19 here, fine. I push another element, or I Enqueue another element which is 19 here, okay. So 1, 2, 3 and 4 and let's make it 5. So in this case, this is the empty portion only, 16, 17, 18 and 19. Now this is the -1 portion, or if I say that this is the empty portion where you had to add something. In this case, now front is pointing out here, front is here, rear is here. Now when I do another Enqueue, what would happen? In that case, if I Enqueue one more element, I say Enqueue 20, I add one more element. Now, unlike the linear queues, here the rear can move forward again and add something here. This was the limitation in the linear queue, if you correctly remember. Even if you had a blank space, if you have reached the last memory block of a linear queue, you cannot add anything until the complete queue is empty. That was the limitation of queue. But here, what I can do is, I create this, and what will happen? What will happen with these disks? Not a big deal. Here 20 would be added, fine. So in the blank space where you had nothing earlier, now you can add 20. I said Enqueue 20, 20 comes here, rear starts pointing here. And if you correctly remember, this was 16, 17, 18, 19, and in this case, this 16 was the place where front was pointing, isn't it? So in this case, you can keep on rotating like this, and whenever you remove another element, it would get removed from here, fine. So this is how circular queues are actually behaving. How to implement it in the code portion, we'll understand in the subsequent videos, don't worry. But for now, just think that how this particular function or this particular way of implementing queue works, because this helps you to manage memory more efficiently, isn't it? What other benefits it offers, we'll understand it in the subsequent videos. But for now, this is the way circular queues behave. And to all those people who are finding any doubt, or they like this video, or if you felt that I have some doubt, I have something to ask that you want to clear, go ahead, comment, because people who are commenting might stand a chance to win the top 3 comments prize, which is the Prep Insta Prime subscription free for 3 months. So you might land up that great chance, and 2 giveaways have been given. We are actually in the process of deciding the 3rd giveaway. So as soon as possible, go ahead, comment, so that you might stand a chance there. Follow us on these social media handles so that you never miss any hiring update, and do subscribe, because that is how you'll get notified about the videos, about the hirings, about anything that I post. Fine. Apart from this, whatever good, whatever thing that you liked in this video, fine. If you learned anything in this video, go ahead, spread it for free. Keep on doing good will come back to you. Okay, so have a wonderful day, have a blast ahead. Thank you.